What we want to do is list here all the energy efficient systems. First of all, the building itself will have all high performance indirect, direct fluorescent lighting. The lighting will have occupancy sensors and daylight sensors. And what this means is that you're going to get the most energy efficient lighting that you can in the building, and you will have sensors that measure the amount of daylighting coming in from the glass that we've been talking about, and the ambient light from the north and the daylighting from the south, to actually shut these fixtures off when daylight levels are satisfied inside of the building. These space-specific zone-sized HVAC heating systems. One of the things we wanted to do in the building is make it so energy efficient that we could actually downsize the energy in the HVAC systems required by the building. We had a day-long meeting, or partial day-long meeting at the fire station, and met with several community groups who were all involved in picking and sizing the HVAC system so that it was properly sized, working close with our builder, Bruss Construction, to actually do some energy analysis and figure out that the more money we put into the exterior envelope of the building and limiting air infiltration, the smaller we could get our HVAC systems and our controls for the HVAC systems, which allow this building moving forward to be as efficient as it can in terms of operating and maintenance. Within this, you will find demand control ventilation for multi-occupant spaces. And what that means is we actually have a sensor on these zone-sized HVAC systems that will reduce the amount of outdoor air required for each space. So if there's no one in the space, the system will actually reduce the outside air intake to 0, which means you'll be heating and cooling recirculated air instead of outdoor air. We have high efficiency split system HVAC units, which are all controlled by a building management system. The reason for this is it provides optimum operation of the systems and also allows internet access to the building management system for the library trustees and the library director to actually be able to turn the heat up or turn the heat down. For instance, on a snow day when the library can't be open, they will actually be able to get into the system from home and shut the heat off so that we're not heating that building on a day that it's not occupied. As said earlier, the south-facing glazing will provide for passive solar heating. As stated a little bit earlier, we talked about enhancing the exterior walls, the roof, and the windows. The walls themselves will have enough insulation that it'll actually be twice as energy efficient as code. As you can see here, there'll be R34, which is the heat resistance through the wall, is measured at 34. The high-performance fiberglass wood windows will also have a U value, which is your energy value, as well as solar heat gain coefficient, meaning it will not allow the sun to overheat the space during the winter. And these values that you see here for the windows are also almost twice as good as code. The roof insulation that we're proposing, that the builder has included in his pricing, is an R60, which means this is almost 2.5 times better than code. And what we're providing is 18 inches of cellulose insulation above the ceiling within the attic space. We're proposing to use point-of-use hot water heaters, which means you will not have to heat hot water throughout the year, maintaining 120 degrees to prevent Legionnaire's disease in your hot water system. We're going to use point-of-use hot water heaters, which means when you turn the water on, you only heat that water that you use, and when you shut the hot water off, the heater goes off. All of the appliances throughout the building and all of the equipment throughout the building will be Energy Star rated. And we're going to commission the exterior envelope, which means we're going to actually measure the air infiltration performance as we're building this building to make sure that the air infiltration is minimized, far exceeding code requirements. The sustainable green systems that we're going to have in the building include all sorts of recycled materials. Working with Rich, we've got approval to use recycled asphalt as a paving base. We talked about our siding earlier, which will actually be a fiber cement siding, which is made of 30% recycled fly ash. All of the building is wood frame, essentially reducing and minimizing, and in fact getting rid of any cold breaks, thermal breaks, and thermal bridging from any metal framing on the building. We're going to use all wood construction. 85% of our insulation is going to be recycled, made from recycled newspapers and paper products. Our cultured stone, which is the veneer on the building, which is going to be the masonry piece of it, is 30% recycled fly ash. Our commercial carpet is going to be a cradle-to-cradle product. Cradle-to-cradle is measured by a third-party independent firm who goes out and makes sure that any of these commercial carpet products are actually 100% recycled, meaning that they can be used for 15 or 20 years, and when they're recycled and ripped up, they're actually made into brand new carpet, and there's zero waste. Our rubber flooring behind the circulation desks is 100% recycled tires. All of the concrete in the building for the foundations will have 10% fly ash in it to reduce the amount of cement required. Our ceiling panels will be made of 60% recycled ceiling panels, which means when there are construction projects in the world going on and they have recycled panel waste, the panel manufacturers actually go out to those sites, collect all those panels, and recycle them into new panels, effectively reducing the waste to a zero waste factor for ceiling panels. The fixtures within the library and the bathroom is going to be low flow fixtures at 1.28 gallons per flush and 0.25 gallons per minute for the water, effectively reducing the amount of water, again, beyond any code minimum. We're going to have porcelain tile floors that are between 10 and 15% recycled materials. All of the sealants and paints throughout the building will be low VOC sealants, which means there will not be any volatile organic compounds within these products. 5% of the gypsum wallboard will be recycled. And again, these wallboard companies now come and pick up 100% of any waste, so that essentially they're going to recycle 100% of all the construction waste generated from the drywall and the wood construction. All of the PVC composite trim on the building will be made from 100% recycled PVC, and all of the wood on the product will have no added urea formaldehyde. And essentially what all of this means is you're getting a building that's going to operate almost 2 to 3 times better than any code compliant building built today, and that's based on 2009 international codes, which are already very stringent and much more stringent than they were back in 2003 or 2006. You're also getting a building that can prove to everyone that we've used sustainable green products and that we reduce the amount of waste, and essentially it's an economy of scale that we're allowed to do this. We were able to work with the local utility company, Unitil, and they will actually take these documents and review them for the moderation and actually provide the town with a rebate. That rebate will actually pay the incremental cost between buying a readily available non-efficient fixture and using this high-performance fixture. Unitil offers this in their new construction program to communities such as yourself who want to take their building and bring it beyond code, bring it beyond the run-of-the-mill, if you will, fixtures, put in energy-efficient systems, and they offer to pay that incremental cost. And in doing that, it allows them to actually save energy that they can then sell to other customers. In addition to that, all of these green systems that you see here are not only recycled materials, but they're proven materials that have been in the marketplace for over 10 years. Given the supply and the demand and the economy of scale that we've been talking about, many buildings, as you hear on the news today, are going green. And based on that, all of the prices for these materials are now either down or actually less expensive than the older materials that they used to use, because the demand for these green systems is so high, and that the manufacture of these green systems are being done by so many more manufacturers today that the competition out there has allowed all the prices for these materials to come down. In addition to that, the maintenance and operating cost for these materials is actually much lower. The more we can use in terms of recycled materials and no urea formaldehyde allows cleaning materials such as just soap and water to clean these materials. We no longer need solvents, we no longer need expensive cleaners to clean any of these materials, and all of these materials that we talked about here come with 20 to 25-year manufacturer warranties.